In this lesson, we're going to solve route inspection problems using the Chinese postman algorithm where needed. This network represents the streets in a town. The weights on each arc represent the time in minutes it would take to walk along that street. If someone wanted to start at point A, walk along all of the streets and then return to point A, what would be the shortest amount of time it would take? So you can see that for this graph, it's possible to do that travelling along each edge exactly once and returning to point A. So the total amount of time is just the total weight of all of the arcs, which is 100. Now consider the same problem, but with this network. So this time, if the person starts at point A, they can travel along all of the streets, but they will finish at point E. That is because the graph is semi-Eulerian, so starting at A, which is one of the odd vertices, the person will naturally finish at the other odd vertex, which is E. So if they wanted to return to point A, they would need to repeat an arc. Choose the shortest of these, which is A to E. This means that the shortest amount of time is the sum of all of the edges, which is 67, plus 8, which is the additional weight of the arc that was repeated. So the total time is 75. So we're now going to consider the same problem again, but with slightly different weights on some of the arcs. So again, the person is going to start at point A, which is one of the odd vertices. They're going to travel along each arc once, and they will finish at E, which is the other odd vertex. The person now needs to return to A in the shortest amount of time possible. The direct edge E to A is 14 minutes, but there's actually a quicker way if they go E to F to B and then to A. So in this case, the shortest amount of time involves repeating 3 edges. So the total time is the total sum of all of the weights, which is 69, plus the weight of each of the 3 repeated arcs, 3 plus 5 plus 4. The total amount of time for this problem is 81 minutes. So far, we've only considered route inspection problems where the person is starting and ending at one of the odd vertices. We're now going to look at one where the person wants to start at vertex A, which is even. However, the network still includes 2 odd vertices, E and B. So starting at A, the person begins to traverse each of the arcs in turn. And you can see that they're unable to complete the journey because they get to E, one of the odd vertices, and they're unable to go any further without repeating an edge. So the solution to this problem is going to involve getting from E to the other odd vertex, B, by repeating some edges, and then they'll be able to continue back to A to complete the journey. So the shortest time to get from E to B is to go ED, DC, CB, and then they will continue on to A. So the idea of repeating edges between odd vertices forms the basis of the Chinese postman algorithm, which we're going to look at in a minute. So the solution to this problem is the total sum of all of the weights, which is 93, plus the additional 3 edges that were repeated. So the total time is 81 minutes. Here we have a problem where a paper boy needs to deliver newspapers to all of the houses in a village. To do this, he needs to travel along each road in the village at least once. He may need to repeat some of the roads in order to do this, but he wants to complete his round in the shortest distance possible. So in order to do this, we are going to use the Chinese postman algorithm to solve this route inspection problem. So in order to solve this problem, we need to change the graph into an Eulerian graph by repeating edges between the odd vertices in order to make them even. So the first step is to identify any odd vertices. The odd vertices are A, C, F, and G. They will always come in pairs. If you recall, the number of odd vertices always has to be even. Now these can be paired off in different ways. We're going to write down the different combinations of those 4 vertices. They are A with C and F with G, A with F and C with G, A with G and C with F. We're going to see which of those combinations of travelling from one to the other gives us the shortest distance, and that is going to be the edges that the paper boy chooses to repeat. We're now going to write down the shortest distance between each pair of vertices. Be careful, these are not always the direct edges. You need to check all possible routes from one to the other to make sure you find the shortest. So the shortest distance between A and C is actually via E, so 23. And the shortest distance between F and G is the direct edge, F to G, 16. Shortest distance from A to F is 25. Shortest distance from C to G is also 25. From A to G, the shortest distance is 29. And from C to F, the shortest distance is 9. So we need to work out which of these pairs gives the smallest sum, as this is the distance that the paper boy is going to repeat. So A to C and F to G gives us a total of 39 and would involve repeating those 3 edges there. A to F and C to G would give us a combined total of 50 and would involve repeating 4 edges. And A to G and C to F would give a combined total of 38 and would involve repeating those 4 edges there. You need to write down all of these sums as part of your solution. So the shortest of these 3 is 38. That means that in addition to travelling along each arc exactly once, the paper boy needs to repeat the arcs involved in A to G and C to F. So the total distance he's going to travel is all of the weights added together plus an additional 38 for the repeated arcs. The repeated arcs are drawn on as a multiple edge to show that that arc has been travelled along more than once. So in adding in these 4 extra arcs at AE, ED, DG and CF, we've made this graph Eulerian. All of the vertices are now even, so it is now possible to find a route starting and finishing at the same vertex and traversing each edge exactly once if we include those multiple edges. So the total answer is going to be the weight of all of the edges add the additional 38 from the multiple edges. If a route can be found now by starting at A, traversing each edge including the multiple edges, and then returning to the start, giving us a total distance of 174. Now complete exercise 2.2 on page 32.